Today we'll be working on the following problem. Let X be a topological space. For all m greater than or equal to 1, let G sub m be an open subset of X. Basically, we have a sequence of open subset of X. Prove that if the intersection of G sub m is empty, then the intersection of the closure of G sub m is meager. It's a meager set. So pause the video if you want to work on this problem by yourself. Okay, let's see how we prove this, right? So basically, we want to show that it's a meager, meaning like it is a countable union of nowhere dense set, right? So we want to show that this intersection is a countable union of nowhere dense sets, right? So if we can show this, that means it's meager, right? So if you look at the graph like this is the topological space, and then there are some open a sequence of open subset, and then if there are the intersection is empty, and then the intersection of the closure of them is meager, right? So here we can this we can do this set operations like this, right? So first of all, this GM, the closure, of course the closure is a subset of X, the entire space, right? So this is like this. But now use the assumption. This is G the closure intersects because this from n from 1 to infinity G m, because this is G sub n, right? Because this is empty, so X minus empty is X itself, right? So the reason we are doing this is like we are able to okay, we just rewrite this from 1 to infinity G closure, and then intersect what? This is we use the distribution law, right? So this is the union of from n from 1 to infinity. This G sub n, the complement, right? This is G sub n, the complement. And now we use the distribution law again for the set operations. This becomes n from 1 to infinity, and then this m from 1 to infinity, the closure of this, right? And then intersect this. You can write down this in this format, right? So now this is actually, okay, if we look at the inside of this, it's the intersection of all such GM bar, right? The closure of this. Of course, it is a subset of, we pick particular n, G sub n, and then the closure, take it. This is a subset of this, right? And then intersect the complement. Okay, now we can see it. This is n from 1 to infinity. And what is this? This is just the closure of G sub n minus G sub n, right? So now from last problem, we know each this G sub n closure minus G sub n is nowhere dense. We just proved in problem 36, the previous problem, right? From this is nowhere dense. And then this union of the nowhere dense set is meager. And of course, any subset, because this is contained, right? So for each n, hence, because of this, right? The intersection from 1 to infinity, the closure of this is a subset of a meager set. This is also meager. That's it.